Welcome to 24th lecture. In this lecture, we will study the Mannan rule, the famous counting rule of probability theory. Before this, we have studied that probability of an event A is the frequency of occurrence for the same event A divided by the total number of outcomes, right? Experimental outcomes, the total number of times the experiment was repeated. So this is the counting representation of probability. The MN rule is that that if an experiment is performed in two stages, in stage 1 it can be performed in m ways, and for each and every m there are n possible ways in stage 2, right? So it seems complex. So let's see, we're going to buy a car which is available in two styles, style 1 and style 2, and 4 colors, 1 2 3 4. So for each style we have 4 colors, so this can be thought of as M and this as N. So car style is M, car color is N, so we have 2 times 4, 8 possible options. Style 1 color 1, style 1 color 2, and finally style 2 color 4. So we have 4 possible options. So if you have experiment performed in 2 stages, we have m ways to select from in stage 1 and n ways in stage 2. So we can have m times n options finally. Or there's another example. The 2 dice are tossed. How many simple events are there in sample space S? For example, if one dice is tossed and we get a 1 on that, and then a second dice is tossed. So for 1 on the first die there are 6 options for the second die. 1 versus 1, 1 on first die, and 1 on second die, 1 on first die, 2 on second die, and finally 1 on first die, 6 on second die. And here we have on first die we have 6 options, and for each option on die 1 we have 6 options for die 2. So there are in total 6 times 6, 36 options. So we are studying MN counting rule, right? For another example is that if we have, now we are going to study some extended form of MN rule. Here we will study an extended form of MN rules where suppose we have 3 coins are tossed. 3 coins are tossed. What should be the sample space, right? For the first coin, if we get a 1 on first coin, we have an option of having a head or tail on the second, and if we have head on second coin, we have an option of having head or tail on the third coin. So growing this tree takes us to 8 different possibilities, or in other words, it can also be thought of in the form of an extended MN rules, where m is the number of times the experiment is repeated, and where m is the number of times the experiment is repeated, and n is the number of options in each experiment. So here we have, for the first option we have 2 possible outcomes. For the first coin we have 2 possible outcomes. For the second coin we have 2, and for the third coin we have 2. So 2 times 2 times 2, there are 8 options, and the same answer, we can reach the same answer by drawing this tree too. So this extended, in order to better understand the extended MN rule, we have another example to solve, where we have a truck driver. He has to go from city A to city D through cities B and C. So if he has to go from city A to city B, he has 3 different options. From B to C, he has 1 2 3 4 different options, and from C to D, the driver has 3 different options. So what is the total number of options in his sample space? That is, he has to he has to travel 3 times, and we have different ends for each of these 3, or for each of his 3 journeys. So first journey he has 3 options, so n1 is 3. For journey number 2 he has 4, so n2 is 4, and 3 is 3. So here is another example, like how can we use extended MN rules. So for these 2 examples, we don't have any m. In fact, m is 3 here, and m is also 3 here, but we don't multiply that with n. Why don't we multiply that with n? Because for every n we have different options. Here we have same options for n, for different options like we have here. We can have different options for different n's. So the mn rule can be an extended mn rule if we have different options for each m. For each n we have different options, so therefore we can write it like this. For m number 1, for m is equal to 1 we have 3 options, for m is equal to 2 we have 4, and for m is equal to 3 we have 3. So therefore we multiply, instead of multiplying m times n, we multiply n1, n2, and n3. So continuing this mn rule, we will take our discussion to permutation and combinations, which are very famous techniques in probability and statistics. We'll study permutations, we'll study about permutations and combinations in our next lecture. Thank you.